Okay, let's go through the even problems here. And I want to do these fast. So let's see. This one here, I'm going to circle my dominant terms. And as n goes to infinity, this is going to converge to 3. All right, this one, our dominant term on top has a higher degree than the one on bottom. So when n goes to infinity, this is going to diverge to infinity. Okay, number 6. Dominant term on top is square root of n. Dominant term on bottom is n. N's going to grow faster than square root of n. So this is going to diverge, or I'm sorry, it's going to converge to 0. This one, we can think of it as like having a polynomial over a polynomial, even though technically square root's not a polynomial because it's got a fractional power, fractional exponent. But we can still think of it like that. Okay, this one, n sine n pi over 2 over 2n plus 1. Okay, for the moment, I want to do this one a couple of ways. For the moment, let's ignore that and think about what would happen. Without that n sine n pi over 2 business, this would go to 1/2 because of the n and the 2n. So this is essentially going to go to 1/2, but this is going to make it alternate, or actually it's going to jump around between 3 things. It's going to make it go between -1, 0, and +1. So if you were to graph this out, that's what your numbers would be doing. So this is going to diverge because it's going to oscillate. And well, let's graph this one. So you've got x sine x pi over 2. There's some fun stuff happening there on the side. Then when you divide all that by 2x plus 1, yeah, you get this. I'm still like way out on the axis. Let's zoom back over. Actually, it doesn't matter. We don't need to zoom back over. If you look at this on all the different integer points, 268, we're at 0. Then we're at essentially 1/2, 0, essentially -1/2, and so on. That's going to continue forever. All right, e to the -n over cosine n. Let's take this guy, let's rewrite it as cosine n over e to the n. So what we've got here is an exponential on bottom. On top, we've got cosine, and we don't have trig functions over there in the chart, but if you think about what cosine is going to do, it's always going to be between -1 and 1. So the top is going to be stuck between -1 and 1, and the bottom is going to grow huge. So what's going to happen to the fraction? It's going to converge to 0. All right, e to the n over 2 to the n. Both of these are exponentials. You could rewrite this as e over 2 to the n. And what is e? It's 2.71, etc., over 2. So when you've got a number like this that's bigger than 1, and you raise it to powers, it's going to grow, so this is going to diverge to infinity. Okay, what about 14? Okay, this one's interesting, because what we've got is 2 different things added together. This is an exponential, and this is also an exponential. Now, what happens to these when n goes to infinity? Well, 1 over 2 to the n, that's going to shrink down to 0. 2 to the n is going to grow to infinity. So when you add these together, you get infinity. So this is going to diverge to infinity. Okay, here we've got a polynomial, and down here we've got an exponential. They're both going to grow, but the exponential is going to grow much, much faster. So this is going to converge to 0.